Hello class, this is Mrs. Ayodeji with today's video on section 11.1 Differential Equations. As you're watching the video, please take down notes, writing down important information, vocabulary, formulas, equations, examples, and the like. For the love of all things calculus, you need written notes on this whole chapter because it's brand new material that you haven't necessarily seen. All right. Feel free to pause, rewind, or replay the video as often as you need so you can get a clear understanding of what is occurring in the video. At the conclusion of watching the video, write down a brief summary in your written notes and submit that summary via the online WISC, as well as the top question the night before the class. All right, let's begin. Today we're talking about a new unit of math, not just a new unit of the textbook, but also a new unit of math. It's a whole entire area of math called differential equations. And so it involves calculus, but in the sense that you need to know what calculus is. So let's look at an example. For example, what is a differential equation? So let's say we want to know how fast a person learns a particular skill. Okay, and one theory, I'm not saying it's accurate, claims that the more the employee already knows of the task, the slower he or she learns. I know it didn't make sense to me. In other words, if Y% is the percentage of the task that has already been mastered, okay, and dy dt is the rate at which the employees learn, then as dy dt decreases, that means that decreases as y increases. So the idea is that the more that the employee knows, the slower the rate at which they learn it. Okay. All right, so here are some example graphs of that situation. And each of these situations, as y increases, i.e. the percentage that the person knows of the task, the dy dt decreases. In other words, we have a concave down graph situation. And each of these situations represent a situation that matches this concept. Okay, but which situation would be accurate? And that's what differential equation is about. So suppose we can equate that the rate that a person learns is equal to the percentage of the task not yet learned. This is a big suppose. It's not saying this is always going to be true. But if this is what we start off as true, then we can quantify that by basically saying since the rate of a person is how they learn is a dy dt, and then y represents the percentage that they've learned, and the percentage that they have not yet learned is the difference between 100 and that percentage that they've already learned. Okay? All right, so suppose that the person starts learning at a time of 0. So they're learning when t is equal to 0, y is equal to 0. So this situation represents that. This situation doesn't, because when t is equal to 0, y is not equal to 0. And when t is, this one does. When t is equal to 0, y is equal to 0. Okay? So that's another supposition. So we have two suppositions. The first supposition is that the rate a person learns is equal to the percentage of the task not yet learned. And then the second supposition is that y is equal to 0 when t is equal to 0. Okay? So that implies that y equals 0 and t equals 0, that initially for the first week of learning, if they initially learn nothing, then that means at that current rate, since this rate is this, and this being is that the rate that a person learns a task is with respect to a week. So in this case, because when y is equal to 0, t is equal to 0, that means dy dt is equal to 100% per week. So ideally, this means that at the end of 1 week, they have learned, if they go with a consistent rate, that they will have learned 100% of what they need to learn. So, but we know that the rate decreases. So let's take a look at just the end of the first day of the week. So at the end of the first day of the 5-day work week, if this is the current rate at which the person is learning, then after 1 day, they have learned 1/5 of the learning, which is, of course, 20%. So after 1 day, dy dt would be 80% per week. So here 80% is a result of the decrease. So it's consistent with the fact that the rate that the person learns decreases. Okay, so at the end of the second day, now we're going to, that the second day represents 1/5 of the work week as well too. But it's 1/5 of the previous days, whatever learning is left. So 80% is left. So that means that at the end of the second day, the rate of learning is going to be 64%, because if you take off the 20% of the previous day rate, which was 80%, we get 16, and we get 80 minus 16. So you now have left over a rate of 64% per week. Again, the rate of change is decreasing. It went from 100 to 80 to 64. Continuing along this train of thought, if I make a chart that represents in times of working days to percentage learned, which is the difference between 100 and each of these numbers, we end up with this table of values to represent the relationship between the day and the percentage learned, i.e. y. Okay? So can we come up with a formula for the solution to this differential equation? And we can. We call any y value that satisfies the differential equation a solution. So any y value that satisfies this differential equation is called a solution. Oops. So there's a whole area of math that comes up with different strategies to find solutions of the differential equation. And for differential equations of this form, we'll figure out the method in the future, but a formula for this solution looks like something like this. Okay, I know you're asking, how do we get that? That's for future units, but just accept that this is a solution of the system. And the reason why we have C here is because we only have the derivative, and so when we in order to figure out y, we had to use some type of integration, and the integration of it over a general an indefinite integral would produce a constant, a family of solutions. Okay, how do we know if this is a correct solution? If it's a correct solution, then if I take dy dt, then I should get an answer that will give me the same as when I take the right side. So in other words, dy dt would be derivative of this suggested solution, and we get negative ce to the negative t. And then since the right side is 100 minus y, then we say 100 minus y would be 100 minus whatever the y solution is. And we get negative ce to the negative t. So it makes sense that dy dt is equal to 100 minus y if y is, as we see here, 100 plus ce to the negative t. Okay, so that's how you check a solution is correct. If y is the correct solution, then it should be able to satisfy the original differential equations, both sides. Okay, all right, so let's talk about the condition that we use to come up with this. It says that when y is equal to 0, t is equal to 0. Well, when time is equal to 0, that's called an initial condition. Okay, and we use the initial condition to find what the arbitrary constant c is. Why? Is because we know what y equals, but when t is equal to 0, we also know that y is equal to 0. So when we plug in t equals 0 up here, and then y equals 0, because that's our initial condition, we end up with c having to be equal to negative 100. So now we have a particular solution that not only satisfies the general solution, but it also satisfies the initial condition. So this is the solution that satisfies the differential equation and the condition that y equals 0 and t is equal to 0. Okay, so just a couple of things. I've used the word general solution. The general solution involves constants. The particular solution does not involve constants because you take advantage of conditions, initial conditions, or the like. So over here to the right, we have various general solutions, well, various forms of the general solution, and we have various particular solutions. So this is a family of functions. This is a particular function right here. In this case, we have different particular solutions that satisfy different initial or conditions. Okay? All right. Last thing we want to talk about is the type of differential equations. We're going to be dealing with first and second order differential equations. First order involves equations that only include the first derivative. Second order differential equations include the second derivative, and that's the highest derivative will include. Sometimes it will also include prior derivatives like the first derivative, but we call this a first order differential equation, and we call this a second order differential equation. If it's a first order differential equation, because of antiderivatives, you'll only have one derivative, one constant. But if it's a second order derivative, then when we find the antiderivative of the second order, we're going to get another derivative that involves a constant, and we take the antiderivative of that, we will end up with a general solution which involves two constants. So in the case of the general solution, the number of constants is depending on the order of the differential equation. Okay? So all you're going to really have to be required to do in order to be prepared for the VA is to know what a differential equation is and be able to determine if a solution satisfies a particular differential equation. You won't be asked to find a solution. That's what the whole unit is going to be about. All right, that's it. Thank you.